Hello, 30-1s. What we're going to do in this video is we're going to use our laws of logarithms to help us solve some equations. One of the things I want you to think about, though, as we're going through this is, first off, never hurts to keep your laws of logarithms in front of you. You never know when you're going to need them. The second thing I want you to think about is these are equations. So I can always check my work graphically on any of these questions. But let's solve these algebraically. Well, the first one I see has an unknown exponent. So the first thing I want to try is to make the bases the same. We can't, so this means we need to use logarithms. So can't make the bases the same. I'll take the log of both sides. Our exponent becomes our coefficient. Now log 3 is a number. I divide both sides by log 3, and that is your answer right there. However, on a multiple choice, they like to use change of base quite frequently to simplify it down to that. But either of those last two lines are your answer. Now, some of you might have recognized that you could have taken the shortcut. And the shortcut is to say, okay, the bases are both the same. Or sorry, there's only one base, so keep the base the same. So log base 3, and my little expression is the other two parts switch because they're inverses. And do you see that that's the final answer we came up with? So the shortcut works in that case because there's a single base. Compare that to the next question where there's two different bases. So here I have to take the log of both sides. No big deal. Take the log of both sides. Okay, the same rules apply. My exponent becomes my coefficient. And I did something wrong on purpose here. I see this quite frequently when students are learning how to do these. Please make sure that 3x plus 2 is in parentheses, because what we're going to do now is we're going to distribute everything out. And if those parentheses weren't there, maybe you forget to do that step. So that's a big mistake. Don't do that. Now let's bring all our x's to one side. It doesn't really matter which side you choose to bring all your x values to. I'll bring them all to the right just for fun. Okay, the one thing you need to know is if I brought everything to the left, I would get the same answer, but it would look a little different. Then on the right-hand side, factor out an x. So I'm going to put some big brackets there so I can tell the difference with where I factored that out. Bingo. Well, log 13 minus 3 log 2, well, that's a number. So now I'm going to divide both sides by it. And I'm actually going to flip, so I have my unknowns on the left. And divide by this. And there we go. Now, our final step here, we could do some more simplification with it. I don't know if it makes it a lot more simple, but yes, absolutely, we could move this coefficient and make it an exponent. And we could do that with that here, and we could start combining and simplifying. To me, what we have in the box is enough, but if it's a multiple choice question, you may have to continue on. All right, so let's look back at these two. Unknown was in my exponent. I couldn't make bases the same. I had to use a logarithm. Compare that to these two. There are already logarithms, but in this case, our unknown is inside our log. So we'll switch it to an exponential. Again, base stays the same. The other two parts switch. So x to the exponent 5 is equal to 3. Now, how do I really want this thing to be x to the power 1 is equal to something. So what I'm going to do here is I'm going to go all the way back to 10c, and I'm going to raise this to the power of the reciprocal. Why did I do that? Well, my power law tells me I'm going to multiply 5 times a fifth, which is 1. So that's really going to end up with x to the power 1. And what are we left with as an answer? 3 to the 1/5. So this is a very common idea here, raising to the reciprocal. Again, if I was stuck on that, never hurts to graph such a thing. Okay, the next one, well, unknowns inside my logarithm. So base stays the same, the other two parts switch. Well, that one's a heck of a lot easier, isn't it? That's just 2 to the exponent of 7. Done. There it is. Okay, if I wanted to verify my work, I could do that quickly. Okay, sub it back in. The 7 becomes my coefficient, and log base 2 of 2 is 1. Verified. Easy peasy. So our most complicated one is this. Well, here's where I'm going to use my laws of logs. I'm going to simplify these together first. Big brackets, parentheses. These are multiplied together. That's what my law of logs tells me. I'm going to simplify inside my brackets first. X squared minus 6x plus 8 is equal to 3. Unknowns inside my logarithm, so I'll turn it into an exponential. Base stays the same, the other two parts switch. Alrighty, well that's 8. I subtract it over, that's 0. Never hurts to factor. So, therefore, we get x is equal to 0, x is equal to 6. Now, I'll see, again, a very common mistake. I'll see a lot of people stop there and say, yeah, that's my answer. Not so. Especially when I start getting more than one answer, I want you to start thinking, maybe one of these is extraneous. Maybe one doesn't work. So I'm going to go and I'm going to look at my domain of where we started. What's our domain of this? Well, let's look at each one separately. The domain of this, well, this graph, if you think of it as translations, has been shifted 2 units to the right. So the domain of this, in shorthand, is just x is bigger than 2. The domain of this one, again, just in shorthand, well, it's been shifted 4 units to the right. So as x is greater than 4. Well, I'm going to choose the more restrictive of the pairs. I will choose then this. This is our domain. So the domain of the original equation is this. X such that x is greater than 4. X is an element of the reals. Or if you wanted to write it like this. So now come back down to our answer. Well, which one am I going to choose? Well, now, sometimes it will be both, but in this case, not this one. I'm going to cross it off, and I'm going to say extraneous. Okay, you have to do both. Cross it off and tell me why you crossed it off. There it is, friends. So this is probably your most complicated logs question, where you have to check the domain as well and using those ideas of transformations of logarithms to help you find that domain. Okay, I hope that helped. Don't forget to graph these things to check your work.